Hello class, I just want to do a homework problem from Math 1430. Homework is from section 6.5. So here was the problem. Find the definite integral from 0 to 9 of 10e raised to the square root of x divided by the square root of x dx. So whenever you want to find a definite integral like this, the first step is just to find an antiderivative or an indefinite integral. Let's not worry about those limits of integration from 0 to 9 until later. So here we have our indefinite integral, and notice this is a quotient, but there is no quotient rule for integration. So typically we try a u substitution at this point, and typically you let u equal the exponent of e. So I'm going to begin that way. So let u equal the square root of x, which is the same thing as saying x to the 1/2 power. Now you find du dx, and by the power rule for derivatives, du dx, you bring down that 1/2, so it's going to be 1/2 x to the negative 1/2, but a negative exponent means it can join the 2 in the denominator as 2x to the positive 1/2, and x to the positive 1/2 is the same thing as the square root of x. So I wrote it like that, 1 over 2 square root of x. So that's what my du dx is after simplifying. So du dx is 1 over 2 square root of x, and that implies when I solve for dx by setting the cross products equal, or you can do it another way as well, you'll get dx equals 2 square root of x du. Now that I have it solved for dx, let's rewrite our indefinite integral using our substitutions. So let's write the integral of, so here I want to rewrite this indefinite integral using our substitutions. So I'm going to write 10e to the u over, I can either write u or square root of x here. Because when I replace my dx with 2 square root of x du, the square root of x's will cancel. So I'm going to make this the u, and if you made this u, you'll see that in order for this to cancel, just change it back to square root of x, because u is the same thing as the square root of x. That's what made this problem a little confusing, because someone wrote about this question. Okay, so let's rewrite the integral as I said. So I've got 10e to the u over, at first I wrote u, but then when I replaced the dx with 2 square root of x, I said, well, I have to get the square root of x to cancel. So I just changed this u back to its equivalent square root of x. Now the square root of x is canceled, so I get everything in terms of u, which is what I want. And then notice 10 times 2 is 20. So I pulled out that constant factor of 20 to the other side of the integral. So this is going to be equal to just simply 20 times the integral of e to the u du. And we know the integral of e to the u is just e to the u. So just write 20 e to the u. And then because I want to get everything back in terms of x at the end, replace that u with square root of x. So there is my antiderivative. So to evaluate a definite integral, which was the original problem, you first want to find an antiderivative. You want to find the indefinite integral. And now what you do is rewrite the problem. So that's what I did over here. So this was our original problem, the square root from 0 to 9 of 10e to the square root of x divided by the square root of x dx. That's going to equal, well, we already did the integral, so all we got to do is write what we got for the integral, and then we're going to evaluate it from 0 to 9. So now we pay attention to those limits of integration. So again, to solve a definite integral, first find the antiderivative, and then you evaluate it from your limits of integration, in this case from 0 to 9. Okay, begin with the 9. Wherever you see an x, you write a 9. So this is going to be written as 20 times e raised to the square root of 9 minus, and now you input the lower limit of 0, minus 20e to the square root of 0. Simplifying, we know the square root of 9 is 3. So it's going to be 20e to the third minus 20e to the 0, because the square root of 0 is 0. So this is going to simplify to 20e cubed minus 20 times 1, because e to the 0 is 1. And of course, 20 times 1 is 20, so I wrote 20e cubed minus 20. That answer is good, or you can pull out that GCF of 20 to get 20 times e cubed minus 1. And that is our final answer. Alrighty, bye-bye.